Good morning, namaskar, vanakkam, sat sri akal to all aspirants. Welcome to the world of scientific language FDP. My name is Dr. Safraz Ahmed, the Assistant Professor, Department of Mathematics, the Assam Kaziranga University. I have privilege of being your host for the session. We'll begin this session with an introduction to Scilab. What is Scilab? Scilab is an open software package designed for scientific and engineering application. It provides a powerful computing environment for numerical computation, data analysis, graphical visualization. Scilab is widely used in academic and industry for teaching research and development purpose. Its open source nature make it cost effective alternate to commercial software like MATLAB. Now I'm pleased to introduce our distinguished speaker, Professor Biju Kumar Dutta. He's an associate professor of mathematics at Assam Kaziranga University and will be our research person for today's session. Professor Dutta research area include stability theory, fluid dynamics and MSD, fuzzy logic and their application, and fractional calculus. His teaching experience, he has more than 15 years of teaching experience in various colleges and university. Presently, he is an associate professor of mathematics at Assam Kaziranga University, a position he was held since August 2013. He served as head of the Department of Mathematics and associate dean at Assam Kaziranga University. His education qualification: he completed his MSc in mathematics from Guwahati University. He earned his PhD from Northeast Regional Institute of Science and Technology. In short, we can say NARIST. New Zealand, Arunachal Pradesh, and his PhD research topic is a study on spatial function, generalized fractional operator, and its application. His publication, he is the author of several books and published more than 20 research papers in various national and international journals. He is a live member of numerous mathematical societies in India and served as a reviewer for many international journals. Under his guidance, four research scholars have already obtained PhD and is currently guiding three research scholars. Please join me in welcoming Professor Biju Kumar Datta. He will guide us through today's session, beginning with introduction to Scilab.
Thank you, Dr. Sarfraz Ahmed. Good morning, everyone. Before begin today's session, I would like to extend a warm welcome to all to this one-week faculty development program on scientific software. During this FDP, I will be presenting two lectures focused on a numerical and scientific software, which is called the Scilab. My goal is to introduce you to Scilab and demonstrate how it can be effectively integrated into teaching and learning, as well as its application within a scientific community. The Scilab is a very powerful open source software used for numerical computation. Throughout my lecture, we will be explore its features, capabilities, and its practical application. By the end of this FDP, I hope you will be feel confident in using the Scilab. Let's begin my presentation. Let's start my first lecture, which is Basic of Scilab, a computation software. First, introduction to Scilab. The Scilab stands for Scientific Laboratory, SCILAB. The Scilab is an open source software package for numerical computation and scientific computing, which is under GPL license. It is widely used for data analysis, algorithm development, modeling, and simulation. Scilab is an interpreted language, and it is similar to MATLAB, Mathematica, Octave, and Maxima. The Scilab has interesting history that spans several decades. Here some overview, its development. Scilab's original origins trace back to 1980 when it was developed by researcher at INRIA, a French Institute for Research uh, in Computer Science and Automation, and ENPC, School of Bridge and Roads in France. It was initially created to provide a powerful and flexible computing environment for scientists and engineers. First official launch First official version of Scilab was released in 1994. It quickly gained popularity in academic and research circles due to powerful competition, flexibilities, and open source nature. The current version is 2024.1.0. The Scilab is matrix oriented, just like MATLAB. Some other key features of Scilab: interoperability. It supports the integration with other programming languages like Fortran, TCL, TCL Tech, C, C++, Java, and other software packages. Provides a wide range of application and workflows. It is free and open source in nature. As an open source platform, Scilab is freely available for download and use. Scilab is widely used in academia and industry for research and teaching purposes due to flexibility and cost effectiveness compared to other commercial software packages. It has community support. Scilab has an active user community and extensive documentation, which helps user to get started and solve the problem they encounter. Scilab interface with other programming language for symbolic computing packages. Next, how to, installation and setup. The main homepage for Scilab is www.scilab.org. You can download and install the Scilab as per your system requirements from its download menu. After installation, you will get this type of console. Now, this console has some naming, that means environment in Scilab, plus console, synode, graphic window, and help. First, I just give you step-by-step process for installation and setup. First, you go to this home page, and there is the option for download. You can download the current version of Scilab. It is 2024.1.0. Or if you are using the Linux system, you can download this tar.xz file, or Macintosh, you can download these files as per your requirements. I'll show you step-by-step installation process for Scilab. First, you go to Scilab main home page, scilab.org, then go to download, and as per your operating system, you can download the Scilab either exe file, tar file, or dmg file. Since I have Windows machine, I'm I'm downloading exe file. Then it is downloaded. It is around 178 MB. Install this file. Before installation, you must remember that your hard disk, it has at least 700 MB free space. Select your language, press next, license agreement, choose your installation directory. Now, as per your requirement, you can check these boxes. I'm consider my default settings here. It's next, next, and then press install. Now installation is completed. Now start your program. This is your default console. Here you can find this is your file browser. This is your main console. You can type your command, your calculation here. This is your variable browser, command history, and this is some news is um, coming here. First, I'll show you Scilab for as a basic calculator. Suppose you want to add two number like 2 plus 3, then you press enter. You notice that this and 2 plus 3 is equal to 5. The answer, it is stored in by default variable answer. Okay, and after that it will display its value. Now in variable window, it automatically create the variable and its type is double. You can view it here. Suppose you want to multiply two numbers like 12 into 11. So 132. Suppose you have to subtract. So 23 minus 15. So you will get this. Now next, suppose you want to find some complex calculations like uh, what is the value of 10 to the power 50 10 to the power suppose 5, so 1 lakh. Suppose you want to find some complex calculations like 12 into 15 plus 105 divided with, suppose 11 minus 20 into 3. So you will get the answer. So you can use the this console as your basic calculations. Next, we'll uh, give you some basic command. So go to my slide once again. Now, basic commands. These are some arithmetic operation like addition, subtraction, multiplication, division, etc. Okay, wait. Okay, division, then power, conjugate transform, and assignment. Now, some predefined variable, percentage I, actually it is used for imaginary unit. Value is root minus 1. Percentage pi, it is irrational number pi. Percentage E, Euler number. Percentage EPS, epsilon, actually it is a machine precision. Infinity, percentage INF, percentage NEN, not a number. Percentage S, actually it is used for symbolic calculation. Especially it is used for calculating real polynomials. Percentage Z is for it is defined for a polynomial variable for complex. It is by default. Percentage small t or percentage capital T, it is for the Boolean variable. Percentage F or capital F, uh, percentage capital F, it is for false Boolean variable. Some common Boolean functions, they are CLC, clear the console, clear, kill the variables, close, CLF, clear, and reset a configure or a frame, unicontrol, who, clock, date, version, PWD, CHDR, MKDR. Okay, these are the basic commands. So basic trigonometric functions: sine, cosine, tan, cot, arc function, inverse function, hyperbolic inverse function, exponential, square root, summation, maxima, minima, absolute, ABS, sine, real and imaginary part of complex number. Now, I just give you the demonstration. First, we start with some some complex number. How can you define one complex number? Suppose A is a variable, I can assign the complex number, or actually for complex number, suppose Z1 is a complex number. I'm defining it like 2 plus 3, now then into percentage I. So A is a, okay, Z1 is a complex number, 2 plus 3I. Now, next, I'm defining another complex number like Z2 is your 5 minus 4 percentage I. So I'm defining two complex number. If you look in the variable browser, so two complex number, it is defined, are both are double, and okay, both are double. Suppose I want to add these two complex number. How can you add? So Z1 plus is a Z2. So the answer is 2 minus I. Suppose I need to store the addition of this complex number in another variable like z3. So is equal to z1 plus it is z2. So so if you look in the variable browser here, z3 is created and having the variable 7 minus I. Suppose you want to find the modulus. Okay, so you can directly find ABS. So if I write it is factorial 3, okay, ABS 3. So this is the modulus of the complex number Z3. Okay. Now suppose you want to find out the value of sine pi by 2. So percentage pi. So it will display the value of, oh sorry, it is sine pi by 2. So sine pi by 2. So the value is 1. Suppose you want to forget about the command. So first you si, okay, and if you press the tab button, you can find all the similar type of command which is starting for si, okay, and then if you write the sign, and then if you want to find out the value like it is pi by 3, okay, so then hit enter button, sorry, wait, and hit enter button, so it will display its value. So you can use this one as a this console as a basic calculator. Similarly, you can easily calculate the value of okay, suppose you want to find what is the value of Euler number E. So it is your 2.7182818. Okay. Now in this slide, okay, if you again I just display the slide here. Okay. Now here you can find the percentage n, s and percentage z. Okay. Now how can I define the variable? Okay. So actually the percentage s and percentage z, these are by default actually these are predefined variable. Okay, you can define the variable as per your requirement, okay, like x. Okay, so first I just use this predefined variable percentage s. Okay, wait. Now here just use this suppose I'm defining p1 is equal to 2 into, okay, 2 into percentage s square plus 5 into plus, sorry, there is a percentage sign I miss here. So p1 is a polynomial of s, so 2 plus s 2 plus 5s plus 2 s square. Suppose I am defining another polynomial p2 is equal to, like this is your percentage s square plus 3 whole square. So it will automatically calculate and display the result 9 plus 6 s square plus s to the power 4. Suppose I want to add, okay, I to find what is the addition of these two polynomial. Just only you have to press p1, okay, you just call p1 plus p2, so it will display the addition of these two polynomial. Okay, now again, suppose someone can type, okay, if you type 1 by 0, so it is infinity. Okay, so if it is not a number, okay, so it will display NaN. Vectors and matrices in Scilab. Vector, it can be defined in the it can be assigned in the following way. Either you can, it will display the submatrix from row 1 to row 2, now this part, and column number 2 to 3, so that means 3 4 minus 1 0. Now you can store this submatrix in another variable like C or D or something. Suppose C equal to this one. Okay, so this one is your 2 by 2 matrix. Now if we use the diagonal, okay, diag of matrix A, so it will display the diagonal elements. Okay, again the trace, okay, the RA, the trace is of matrix A is 10. Okay, in another way, if I use the commands sum and the diag of A, okay, so it will display the same thing. Okay, now in similar way you can find the maximum of maximum, okay, a minimum element and the maximum element, okay, in the matrix A in this way. Again, if I use the length here, the length command of matrix A, then it has altogether 9 elements. Now if I use the size command, size of matrix A, it is a 3 by 3 matrix. Again, the determinant of A, right, so it is determinant is minus 23. Since determinant is not 0, the matrix inverse exists. So now how can I find the inverse? Also it is the inverse of A. So this is inverse of matrix A. Now next, some basic operation. Suppose you want to add two, okay, add two matrices. Okay, before that, suppose I'm creating one matrix B, so it is a 3 4 5 and then 7 8 9, then 4 6 3. So the matrix B is created. Now if I use, is both matrices are same? No. Okay, but element, okay, um, third row first element, it will same with matrix A. You can easily verify. Now because both matrices are 3 by 3, so matrix addition is permissible. So you can find A plus B, A minus B, this way. Now the product also you can find. Okay, so this is a product. Now sometime if you want to find the element wise product, okay, in between matrix A and B, then you can use now dot. Okay, so actually the dot, it is used for element by element. Now but if I use dot plus B, it will display one error because the matrix addition is element by element. Okay, similarly the matrix subtraction is also the element by it is subtraction is also element by element. Okay, so that's why it will display the error. Okay, so since it is element by element, simply you have to use A plus B only. Okay, now next part, suppose you want to create one zero matrix of the dimension 4 by 4. Okay, so okay, sorry, it is zeros. Okay, it is zeros. Okay, 0. So all the entry, it is 0. Okay, now if I use ones, okay, 4 comma 4, so all the element they are 1. Now how can you create one identity matrix having dimension 4 by 4? So I command, it will create identity matrix. Suppose for your practice, you want to, every time you have to enter the matrix. Okay, so the system can generate, okay, by using the random command. System can create the matrix, okay, in between the element in between 0 and 1. Suppose if I use RAND, then the 4 comma 4, so all the entries, it is in between 0 and 1. Suppose I'm using here, okay, suppose I'm multiplying here, it is 10, so it is 2.7. Okay, now look earlier one and, okay, look earlier output and this output. Okay, so since it's a random matrix, every time the value it will change. Now if you want to find the rank, okay, suppose I'm defining a matrix, suppose A is a matrix. Okay, A is a matrix 4 by 4, and I want to find the rank of, okay, matrix A. Simply you type the rank command, so it will display, okay, it will display 4. So this rank of this matrix is 4. Okay, now the next part, suppose if suppose instead of that random matrix, suppose I have to generate a integer random matrix. Okay, so at that time, okay, you have to simply write here int. Okay, so and then this, so this is your random integer matrices. Okay, again if you use it, then you have to notice that every time the value, it is changed automatically. Okay, next, okay, next some properties of matrix, multiplications. Wait, Now vector, it is done. Oh, okay. Now some properties of matrix multiplications. Suppose, wait, okay, I'm using the pen. Suppose I have a matrix A. Okay, A is a matrix of size m by n, or you can write it in this way. Suppose it is A I J, it is your m by n. The matrix B is of size like it is your B I J, it is n cross P. And matrix C, suppose it is your Cij, it is your P cross Q. Now first we have to verify, okay, for any random matrix whether this property, okay, so this property, whether this property is satisfied or not. Okay, now if we apply the matrix multiplication, then so obviously we have to find a matrix multiplication, and ultimate result of this one is nothing but m cross q. Now how can you verify okay, how can you verify this statement, okay, for any random matrix? Now again go to, okay, okay, first I clear my console. So command is CLC. Okay, now suppose I'm defining a matrix. So first matrix is suppose of the size, it is your 5 by 4, and suppose I multiply it 100. Okay, it is depend on it. So this is a matrix having two elements. Okay, now defining another matrix B. So B matrix is n by p. Okay, so matrix B is your B, suppose n is suppose 4 and this is suppose 3. Okay, so matrix B is created, and in similar way I can create the matrix C is suppose 3 by 2. So it is a 3 by 2. Okay, now if I write here, so AB matrix, and then C, whether this value is equal to, okay, first I'm finding this value. So, and what is size? Okay, so if I use the command here, the size, okay, the size is nothing but it is 5 by 2. So first statement, it is verified. Next we have to show whether the equality hold or not. For this, okay, I just write down here equal to, I just compare here equal to, now A times matrix B into C. Okay, so all the element there. So suppose I say the matrix A, matrix B, and then matrix C once, and also say whether they are same or not. So every time the value, okay, so they are same. Okay, so it is it is verified. Okay, by taking some example. Next part. Okay, next. Okay, next. This is suppose problem number, suppose 1. Okay, now problem number 2. I'm just consider A is a matrix whose dimension is suppose m by n. B is a matrix. Okay, so it will be Ij having same dimension, and C is another matrix of C Ij. Okay, and its dimension is n by p. Next, we have to verify the right distribution law. Okay, the right distribution law is, it is A plus B into C is equal to A C plus B C. Okay, in similar manner you have to also verify the left distribution. um, okay, in similar way we have to verify it. Okay, so first I'm just consider this one example. I just verify through um, some matrices. Okay, again I go to my Scilab here. Okay, first I define the matrix A whose dimension is, suppose matrix A is that one, and matrix B I just change it to, because both are having the same dimension, so 5 and 4. Okay, so I'm writing this your matrix B. Okay, then matrix C I'm defining here. Okay, matrix C is, suppose it is 4 by suppose 3. Okay, now first A plus, so as per right distribution, so this is the value, and I just compare whether this value they are same with AC plus B into C, or okay, so yes, so it is verified. So you can easily verify for our different problems. Okay, now again go to my slide once. Okay, this is my slide. Next, some property. Okay, some property related with the determinant. Suppose I'm just consider one square matrix. Like suppose A is a square matrix of size n cross n, and B is another square matrix of same size, so it is n cross n. First property, it is AB is equal to, no, it is A B. Number 2, A plus B is not always the addition of these two determinants. So we have to verify, okay, these two. Go to now. Okay, here suppose I'm defining one random matrix. Suppose this is my matrix A. Okay, suppose this is my matrix A, its size is suppose 5 by 5, matrix B. Okay, so matrix B is same. Okay, 5 by 5. Now, so how can I find the determinant? So you can use the command determinant. Okay, so determinant of matrix A is this one. Okay, now first we have to verify AB determinant is equal to determinant of A plus determinant of B. So I'm just writing here determinant of A times B, whether they are okay, whether this value is equal to the value of the determinant A into determinant and B. Now actually this result is true. Now if you find it out, the determinant A cross B, so it is a very huge number. Again this one is very huge number. Okay, so due to conversion, so uh, it will display the false. Okay, now if I consider the metric, okay, if I consider, suppose this is your matrix of 3 by 3 and I'm assuming, suppose matrix A is like this and matrix B is I'm consider, and if I verify once, okay, so it is a truth. Okay, it is a true. Okay, since the earlier result is very huge, that's why due to some precision it will display. Okay, it will display this. Okay, next, whether this addition, okay, they are same or not. So determinant of A plus determinant of B. Okay, so this will not always true. Okay, by considering some example you can easily verify. Okay, in this way you can easily verify. Now another important thing is sometimes you can create the vectors. Okay, like suppose if I create a vector, okay, like 1 colon suppose 6. Now if you notice here, so it is row having 6 element. Okay, it is a row matrix. Now every element, okay, the difference between every element is 1. Suppose if you want to write here 2, so it is increment by 2. Okay, and you can store, okay, this one, okay, the store it, and it is just, okay, 2 6. Okay, so this is your vector. You can do a lot of operation. Similarly, in similar way, if I write it here, suppose uh, it is now 0 and it is like 0.5 to pi. Okay, so one, so it is a vector having 7 elements. Okay, use spaces or you can use the comma. First, I just show you how I can define the vectors. Okay. Suppose I am defining a vector A. Suppose vector small a is equal to it is 1, 2, 3, okay, 4. So you have so the vector it is created and its dimension is 1 by 3. Similarly, the vector b, it can be defined. Suppose it is 2 comma 3 comma 4. Okay. So this is another vector b. Suppose I have to find the transpose of vector a. So a, that's right, apostrophe. So it is a 1, 2, 3. It is a 3 by 1. For access, for accessing the position, okay, of an element, you can simply write a. Suppose I want to access the third element. So I first row third element, which is F3. Similarly, suppose I want to access uh, uh, access the second element from the vector B. So it is your first row second element. Okay, so you can define you can uh, display the second element in this way. Now size command, if I use the size of a, it will display the size of the vector a. So first one it is for row, second one is for denoting the column. Now length, the length of vector a, it is 3. Suppose you want to find the mean, then write the vector a. So this is the mean. Now again, if you want to find the maxima and minima, simply you just type mean of vector a. Okay, so minimum is 1 and the maxima is, suppose, oh sorry, so, 8. Now if you notice in the previous error, now it will display, okay, where error is. So it is a syntax error. Okay. Now suppose I want to find what is the sum of the element of vector a. So it is nothing but it is 6. Next, since we have vector a and we have vector b, suppose I want to compare these two vectors whether they are same or not. Now if I write a equal to b, now it will display false, false, false. So it will just compare the element wise. Okay. Next, some arithmetic operations like earlier one. So you can use a plus b. So it will display addition, a minus b subtraction, or b minus a, again the subtraction. Now multiplication. If I use a cross b, okay, a into b, it will display the error. Okay, error due to wrong dimension. Now, how can you find this? How can you find? So simply you type A star A into B and it's a transpose. So it will display 20. Suppose you want to find suppose you want to find the magnitude. So how can I find the magnitude? For finding of the magnitude, simply use a magnitude of A. So it is just, so it is a 14. Okay. Now next, if you want to find the cross product between the vector A and B, simply use as write the cross, then okay, so cross, then A comma B. So it will display the cross product between these two vectors. Now you can easily verify whether A cross B and B cross A they are same or not. Simply you just type it here B or A. Okay, so if you compare with, okay, so they are not same. So it is there is one minus, since we know A cross B is equal to minus B cross A. Okay, next part we just go for the matrices. Okay, so how can you define one matrix? Suppose capital A is a matrix containing the element 2, 3, 4. This is your first row, then 3 minus 1, then 0, second row, and third row is now 4, 5, and then 9. Okay, so the matrix A. Next we learn how to solve system of linear equation in Scilab. I am consider one example. Now first we have to write this system of linear equation in the form Ax equal to B, where the matrix A is nothing but is a coefficient matrix. Coefficient is 1, minus 1, 1, 2, 1, minus 3, 1, 1, 1. Then matrix, the vector, okay, column vector, it is a 4, 0, 2. Okay, so where now if this matrix A is invertible, okay, if this matrix, the determinant of this is not equal to 0, so A inverse exists. Therefore this one, it can be solved, the x can be solved by using this formula. That means it is A inverse into B. Okay, so in Scilab, okay, in Scilab we have to write it here, inverse of mat A times B, or you can use lin solve command. So A, then minus B. Now you must be careful, there is the negative. That means you have to write the column vector in your left hand side. Okay, and then you have to comment. Okay, so I just give, okay, the demonstration in the Scilab and go to Scilab. Okay. So matrix A, first we have to import the matrix A. It is your A. Okay. First I clear my console. Okay. Then I am writing here A equal to the matrix A is your it is your 1 minus 1 1 minus 1 1, then type 2 1 minus 3, then type 1 1 1. So this is a matrix A. B, it is a 4 0, then 2. Since this one is a column vector and I'm uh, I'm just consider vector B is a row, so simply you have to transpose it. Okay, so this will be B. Now how can next we find the determinant of A. It is a 10. Fine. So it is invertible. Simply use this right inverse of A to B. Okay. Again, you can use linear solve command. So it is A, then minus B. You are getting the same answer. Okay. Now, how can you find that means eigenvalue and eigenvector of a matrix? Okay. Suppose I'm consider okay I'm consider matrix A. Suppose I'm consider matrix A is a random matrix. Okay, so random of size 3 by 3, and suppose I multiply it by 10. Okay, simply you use spectrum of A. Okay, so all eigen values they are real here, since imaginary part is okay, multiplied with 0, so it is real. Now if you want to display um, corresponding eigenvectors, okay, so simply you just consider any variable, suppose EIGN vector VECT, suppose, and another one EIGN short form, and suppose value, then write it here spec SPEC of A. Okay. So this is your corresponding eigen. These are your corresponding eigen vector and value. First one, okay. So these are corresponding eigen vector. Okay, fine. It is created. Now, in similar way, you can find what is the transpose. Okay, and suppose you want to find what. Suppose in the position 2 comma 2, okay, 2 comma 2, element in the position 2 comma 2, it is your minus 1. Okay, suppose you want to display, okay, suppose you want to display all, wait. So suppose you want to display the second row element. Okay, so the for second, all the second row element, it can be displayed by uh, column. Okay, two, first one is for row number and column is for all. Okay, now suppose you want to display the third row, so how can you write? So a, then colon, comma 3. So this is your third. Suppose you want to find some submatrix. Okay, suppose matrix A is this one, and suppose I want to create some submatrix. Okay, so A 1 colon 2, then comma like 2 comma, suppose it is 3. Now it will just extract row 1. Okay, row number, okay, it will create submatrix row 1 and 2. Next we discuss how to define the polynomial in Scilab and some basic operation related with the polynomial. Okay, later we just do some symbol calculation here. First I just clear my console. Okay, clear, look and CLC using here. Okay, now the polynomial, it can be defined into two ways by using its root. Okay, and suppose I'm defining the polynomial by using the root. Okay, uh, and you display here, this is a comment using root. Okay, using roots. Now suppose p1 is a polynomial, we can use the poly command. Then suppose its roots are like 3, 4 and suppose 5. Okay, 3, 4 minus 5. So and x is a variable. Okay, and then these are the roots, r is roots. Okay, so we are creating the polynomial. Okay, now instead of this, if I simply write, okay, so it will display the same thing. Suppose if I write it here, comma, suppose p2 is the polynomial 3, 4, 5, and then if I write it here, to see it, what does it mean? It will create the polynomial having the coefficients 3, 4 and minus 5. Now you can we can do lot of operation. Suppose if I write p1 plus p2 addition, we are getting the addition. Now if we write here, then p1 divide p2. Okay, so it is a rational. Okay, it is of the form p by q form. Now if we write it here, type of, so type of command. Okay, so type of, if you write p1 then you notice that it's a polynomial, and then this one, it is nothing but it is a rational. Okay, and now if you want to find out like derivative, okay, so write d r I derivative, so command of p1, similarly derivative of p2. Okay, so you can easily verify it. Now, okay, so p2, so derivative is obviously 4 minus 10x. Okay, so we can easily verify it. Now again, since we have a polynomial p1, now again if you want to find the root, okay, so command is roots, then type it is p1, so minus 5 4 3. Okay, so earlier we are using this command for creating that polynomial, so 3 4 minus 5, so these are the polynomial. Now again if I use the command degree, okay, so degree of p1, so to display the polynomial, okay, polynomial degree. Now if I use the command nar, then p1, then suppose this value is, suppose it is your 1, it will display when x equal to 1, similarly when x equal to 2, or if you want to display suppose like, so in between 1 to 10, okay, you want to display these values, so you can use this one as a command. And you notice that is a 1 2, and because 3 and 4 are the root, so that's why you are the position 1 2 3, third position and fourth position, this will be 0. Okay, or instead of this if you write minus 5 to 5, so minus 5 is a root, that's why it is a 0. Okay, and then okay, before this one it is before 20 it is 0 and 0. Okay, in okay, now in the derivative command, okay, if you write it here, so p1 by p2, so this is a derivative of the rational function. Okay, you can easily find out its derivative. Sometimes the polynomial, okay, you can create like, suppose t is poly, suppose I want to create one okay, instead of suppose x equal to, suppose the poly in 0 comma x, so this line it will create x is a variable, okay, this x is a 0-degree polynomial, it will create it. Actually this for symbolic calculation purpose we are using this one. Now in some time the polynomial, okay, for the calculation purpose, suppose if I write suppose p3 is equal to, now it is your, if I write it here, 2 times x square plus x then a whole cube. So for some symbolic calculation, you can define the polynomial in this way. Okay. As discussed earlier, different environment in Scilab, they are a console. We are using this console for our calculation purpose. Then we already use the help command. Okay. Next, suppose you want to write a program, then you can use the Synode editor, or if you want to display the graphics plots, then you can use the graphic window. Okay. Now, how you write the program in the Synode? Now, in Scilab a console, okay, you just at the top you notice there is an icon, the first icon, a notepad and one pane. You can press here, and one editor is a pop-up. So this editor, it is nothing but it is a Synode, and you can write your programming here. So it is a small size. I just since the font size first, yes, set fonts, and I just okay, and it is around suppose 30 or 24. Yep, here it is on board. Right. Now here already we've done a lot of coding here. I select some coding. Okay, so right down there. So actually it is, this coding is nothing but we are equating whether it will satisfy this property or not. Okay, and suppose I do display this value, so you can use the command display. Okay, display this matrix, and then display the size, and then display whether they are equal or not. Display whether they are equal or not. Now first we save it. Save, suppose give it my example one. Save. How can I compile? For compilation we just hit this execute here, so it will execute it. Okay. Now if you want to give some input here, my product, then you will notice that save and execute. So this will the my, okay, this will display the my product. If you want to display this thing at the beginning, then simply copy, paste, and then like this, so it will display it. Okay, and then you can write size. Okay, size is a string, this string is a display here, and then save and execute. So this is this is a matrix and size, its sizes if I were to, and all the value they are equal. Now again, oh, different flow control. Okay, the flow control statements. It is your if else and select case for while break. Okay, in next lecture I'll discuss the different control statements in the Scilab. Thank you.
Thank you, sir, for your mesmerizing and wonderful presentation. I think it helped to every aspirant who are attending fabulous scientific language FDP organized by Department of Mathematics, the Assam Kaziranga University.